Intermolecular forces are the forces between molecules that cause molecules to be attracted to one another. Covalent bonds are not examples of intermolecular forces. There are several different types of intermolecular forces. London dispersion forces, which are present in all molecules, dipole-dipole forces, which exist between polar molecules only, ion dipole forces, which exist between ions and polar molecules, hydrogen bonds, which are not bonds, but they're a special case of dipole-dipole interactions, and ion-ion forces, which is otherwise known as the ionic bond. London dispersion forces exist between all molecules as a result of molecular orbitals. London forces may be strong or weak depending on the size and shape of the molecule. In general, larger, more spread out molecules tend to have stronger London forces, whereas smaller molecules tend to have weaker London forces. London forces are the result of temporary dipoles that are formed between adjacent molecules. It's also worth noting that London forces are the only kinds of intermolecular forces present in nonpolar molecules. Dipole-dipole forces exist between polar molecules. Polar molecules, by definition, have areas of partial positive charge and areas of partial negative charge. When two polar molecules are adjacent to one another, the partial negative charge of one molecule lines up and becomes attracted to the partial positive charge of the adjacent molecule. Ion dipole forces exist between ions and polar molecules. These forces primarily come into play when an ionic solute is dissolving into a solvent like water. As the solute dissolves, the cations will start to coordinate or surround itself with the negative charged areas of the polar solvent molecules. Similarly, the anions will surround themselves with the partially positive areas of the solvent molecules. Hydrogen bonds exist between polar molecules that contain nitrogen, oxygen, or fluorine atoms. In addition, the adjacent molecule must have a nitrogen with a lone pair of electrons, or an oxygen with a lone pair of electrons, or a fluorine with a lone pair of electrons. When these conditions are met, a hydrogen bond can form between the electron pair of one molecule and the hydrogen atom attached to a nitrogen, oxygen, or fluorine of an adjacent molecule. The most common example of hydrogen bonding is with water, because water contains both a hydrogen attached to an oxygen as well as an oxygen with a lone pair of electrons. Hydrogen bonding can occur between two different molecules as well. For example, ammonia can hydrogen bond with water because ammonia has a nitrogen with a lone pair as well as a hydrogen that's attached to a nitrogen, and water has a hydrogen that's attached to an oxygen as well as an oxygen with a lone pair. Hydrogen bonding is prevalent in biological molecules such as DNA and proteins. Ion-ion forces are electrostatic attractions between adjacent, oppositely charged ions. Ion-ion forces are also known as ionic bonds and can be quite strong, in fact the strongest of all intermolecular forces.